Oh, good morning. It is a stunningly beautiful day here at the cabin at Olive Lake. Finally, after days of wind and rain and cold weather, things are finally starting to look up. I'm sure the bugs and black flies, mosquitoes will all be out in full force. Over the course of several videos that I've done, I've been asked a lot about my solar system, so I wanted to, in this video, go over my complete off-grid solar system. Um, the origins, the cost, the reason that I chose this system, how it is that we got it installed, the things that we can power, and just give you some background on that. This cabin was built in 2015 for the most part, so it's getting on to be 5 years old. The solar system is 5 years old, and it's performing flawlessly now. A lot of kinks that I had to work through, a lot of mistakes that I'll discuss a little later on in this video, costly mistakes. But overall, this solar system gives this cabin life for its intended purpose. So, a little bit of background. We're up in Woodland Caribou Provincial Park, and for those of you that don't know where this is, it's one of the northernmost provincial parks in the Ontario Provincial Park system. This is a truly off-grid cabin, and there's a ton of videos on YouTube and elsewhere talking about off-grid systems, and I encourage everyone to check them out. Some of them are really off-grid, and some of them are closer to the city, let's say, where you're able to get supplies, drive to a hardware store. We don't have that opportunity here. Everything that you see and that you'll see throughout the series of videos that I'm going to do this summer has been flown in by floatplane, whether that's on a little Cessna 185, whether it's in a de Havilland Beaver, or an Otter, or a Cessna Caravan. Everything is flown in. Even the boats and motors, canoes, building material, everything's been flown in. So when we were developing the idea for this place and developing the solar system, that always was in the back of our mind. Because you can't just go to a hardware store. You can't just drive half an hour and grab a supply or a fitting or a wire, anything like that. So we had to do it right the first time, and for the most part we did. To show an actual map reference of where it is that we're located, the cabin is right here on this lake, Olive Lake. So that's where I am on this eastern shoreline. And this is in Woodland Caribou Provincial Park. I'll just move this so you guys can see it's just all water. Water and land. There are no roads in here. So when I mention that this is completely off-grid, the only way to access this cabin is either by floatplane or ski plane in the winter time, or to paddle in. Paddling in would not be an easy feat. It will take several days to get into this lake. Of course, this is a canoeing destination for the most part. There are some cabins out here as well in other parts of the park, but there's no roads. The idea of this cabin was to have a completely off-grid, self-sustaining accommodation. This is a commercial cabin. We rent this out weekly on any given year other than a COVID year. This place would be occupied right now by fishermen and people seeking a green experience, wildlife photographers, people just looking to get outside and enjoy the outdoors, staying in a cabin, going out for the day, and then coming back in the evening to a beautiful cabin. So on that note, it was a commercially designed cabin, and it's not as rustic as a lot of other cabins that you'll see. It's not. It wasn't designed to be. It's not a log cabin. It wasn't designed to be a roughing it kind of place. It was designed to have all of the creature comforts of home, whether that be hot water, lights whenever you want, proper cooking setup, you name it, we have it here. And that all is designed around the solar system. So when we were designing it, we wanted it so that people could turn on a light whenever they wanted. Didn't matter if it was cloudy for 3 days. It didn't matter what was going on. If people had a CPAP machine, if people wanted to make fondue, if you wanted to build something else and use other power tools, miter saws, table saws. It doesn't matter. Everything is powered by the solar system and the battery bank that we have. So that's really what this place is about. It's completely off-grid, not as rustic as others out there, but it wasn't designed to be that. Hey, buddy. Hey, come up here. Up. Mosquito's going to enjoy me for the view here. So, as I was mentioning, endless power. That's really the goal here, is to enjoy your time and never have to worry. It was also engineered for winter. So for this time of year, it's overkill, okay? And I know someone will say that in the comments. Absolutely, I agree with you. Completely overkill for the summer. This is not a setup that you would require for summertime use unless there was a lot of power being drawn all the time. Most times, we'd never even use the power that's being generated on a minute-by-minute basis. It's just all stored in the batteries, which is great. It's great when clouds come over for 3 days, but the bottom line is it was engineered for winter use. So in winter, the angle of the sun is obviously lower or less, whatever you'd want to say. It's not as powerful. So we needed to come up with a system that was going to enable the same style of experience that people have in the summer in terms of power use, but in the winter. And our panels tilt. So in the winter time, they're tilted at not such an aggressive angle to help shed snow and to capture that lower angle of the sun. And then in summertime right now, June 5th, they're going to be tilted pretty much, I'm not doing a good job of this, but pretty much like that. And I've already tilted it. I did it yesterday with the help of my wife. We tilted the panels. So right now they're sitting in the sun. I'm watching them, and they're soaking up all the sun. So it was engineered for winter. So you can come out here in the winter, and I do. I've spent up to 2 months in the winter here, all alone, and never worrying about power, except for the one time that I blew up my batteries because they froze, and I'll get into that in a little bit as well. Anyways, why don't we check out the solar system? I'll show you guys the panels. They're 250 watts each. So 6 panels in total. I'm generating 1,500 watts. I'm not sure the ampage. I'm not an electrician, by the way, and never wanted to be, never will be. So there might be some things that I'm not stating. Ask me in the comments, and I'm happy to research it. But 1,500 watts, that's what I know for sure. We're generating at 6 panels, 250 watts a piece, going to my batteries. And I'm going to list, by the way, in the description of this video, pretty much the specs of this system, from the inverter system to the batteries, panels. I'm going to try and list it all in the description so that you guys can actually see what the whole system looks like. Maybe there's something here that'll be of value to you, and I hope that it is, because that's what the whole point of this is. I just want to show you what system I'm using, and if anyone out there has any hopes and dreams or reality of putting together an off-grid system that's completely self-sustaining, that they can use for everyday life as if they're in their house, this is what it is. So let's get to it. This is where it all begins, on these panels, and you can see that there's some give to them, there's some flex. This system has already sustained wind gusts over 60 kilometers an hour. That's got to be over 40 miles an hour. It was engineered by a contractor with the concrete pad that was poured to withstand these winds. Basically, I'll show you the pad here in a second, but there's 6 feet of concrete down in a hole with rebar, made a big pad. So this slab weighs thousands of pounds. It's a pole mount system, and you can see the tilt, right? You can see the angle that it's on right now. These are pretty hot to the touch. A couple days ago, before we tilted them, they were like this. I might be able to send you a picture or show a picture in this video, but now they're soaking up the sun at a flatter angle. It is it's 10:45 in the morning right now, June 5th, and the sun is already really high. So before I had tilted these like this, the top of the panels would have been getting this morning's sun. The bottom panels wouldn't really, because the cabin would kind of be blocking it out. But now, as you can see, everything here is generating power, loads of power. It's awesome. So I'll show you the actual system in behind here now, and then we'll talk a little more about it. All right, so the framing system, you can see this is aluminum racking. So the racking system that these panels are installed on, it's aluminum, very strong. And I mentioned how yesterday I had tilted the panels. So there's one main bolt right in through here where my finger is, and then there's 2 friction clamps on each end. Same thing with the other side of the mount. So to tilt this guy, you can just take this bolt out. I don't know if you can see that with the camera angle. Reduce or release these friction clamps. Do the same thing on the other side, and then this thing will slide. It's usually a 2-person job. Tilting it at a less of an angle like it is for the winter, it's easy because gravity allows it to fall, so 1 person can do it. But it's pretty much a 2-person job in the summertime because this system has to get lifted and the bolts have to go into specific places. But basically all the wiring is up here, so each panel is wired going to the main breaker panel, which is right here. Pole mount, so that's a big steel pole. And then what I'm standing on here is a concrete base. So this base is going to be, looks about 6 feet by 4 feet, 4.5 feet. And I think the actual slab itself is down about 2 feet, and then there's another hole that goes down 6 feet, and it's all full of rebar. So it's going to be structurally very sound. It was engineered that way, and we poured it, and shouldn't be an issue. Don't mind all this tech cable. We had a lot of cable that we flew up here to do the job. It's okay sitting here, I believe. I'm not an electrician, so if anyone else knows, let me know. But conduit, so it shouldn't be an issue. There's no issues with mice or sun or anything like that. The actual wiring itself is going to be stable. But yeah, this is basically the system. Now if I take my 2020 compass out, my iPhone, and I look to see where this pole mount is facing, it's 181 degrees south. That's pretty perfect when it comes to this kind of a deal. So it's facing south, and the reason for that is obviously to get the most amount of sunlight that you can, and looks like they did a good job. So the panels themselves have their own shut-off. So you just lift this panel, and you have these breakers here. There's 2 breakers. Obviously, they're both on right now. In the wintertime, if you wanted to completely isolate and shut this system down, you can just pop these breakers down. I don't. I personally leave this on. I let the panels just do their thing. But if you wanted to shut it down, you could. So the cable comes from the solar panel pad. It's buried in the ground all throughout this sand. This area right here, by the way, is disturbed because I had to dig up my gray water system. That was in a video last week. But basically the tech cable, or the cable from the solar system, runs up underneath. Kind of comes underneath the boardwalk that we've created, and it's going to the inverter system, the charge controller, the guts really of the entire system. So let's go check that out. So now we're at the panel. This is where the brains of the operation is. And again, I'm not an electrician. I really don't know what I'm talking about in terms of technical specifications. I only know about my experience with this system for 5 years out here. So again, don't be too harsh on me. But essentially, that cable that's running down from the solar panels, buried underground, it's going to connect up right here. So our power, our tech cable, our cable coming from the solar panels, it's coming out of the ground right here. And it's coming up on this post. and it's coming straight into our Schneider electric inverter, charge controller, that whole deal. This other cable that you're seeing here runs to a very large cord, basically an extension cord, which we can plug into the generator if we do need to charge the batteries, because it's just been days and days of cloudiness, or any reason our batteries drain down, or if we need more power, which hasn't really ever happened before. But we have the ability at a moment's notice to plug in the generator and get this thing charged up. I'll go into the generator in a little bit, but it takes maybe a couple hours, 2 hours of charging on the generator, and this thing is good to go as if it was fully charged. So that's where it's coming out of the ground, and it's coming up into this beautiful, beautiful system here. All right, the guts of the operation right here. So this is a Schneider Connex SW controller here and inverting system. We also have a Xantrex XW SCP. I have no idea what any of this means, guys. Like, my mind is blown. It's all made by Schneider Electric. And then we have our Connex MPPT 6150 Schneider Electric solar charge controller up here. So basically, this is the whole operation. These are your breaker panels. When I leave in the wintertime, I just shut this whole thing down, and then there's no power at all being sucked from the panels and going into the cabin. You can see that the tech cable or the power cable comes down and then into the cabin right there. But this is a pretty sophisticated piece of technology. It's computerized, and it allows you to tell this thing how to charge, when to charge. It's a pretty smart unit. I don't get into the meat and potatoes of it, to be honest with you. There's probably a lot that I could learn by just diving right into this, but I have it set up so that it just works for me when I need it to work for me. And maybe it's fear of not knowing what I'm going to do if I make a mistake, because if something happens to this, if I set up a wrong setting, you're looking at like $2,000 just for a flight to bring in materials. And that's a lot of money I don't have. So it's set up the way that I need it to be set up, and it's good enough for now. I don't know if you guys can see this with the sunlight and the glare, but there's an AC and a PV. PV, I think, stands for photon or whatever, photoelectric, I don't know. But when the sun is up and there is power being generated from the panels, this has a blue light. So this breaker, or whatever you want to call this thing, tells me that right now we're making power, and that's a good thing. So this little digital readout right here, there's different settings, and you can learn a little bit about your system. But what it's telling me here is my output right now is 41 amps. My battery level is 27.1 volts, 1200 watts. It tells me that my harvest is at 73 amp hours. I'll just scroll through this here. Status, battery. So my battery's sitting at 27 volts, and my load is sitting at, right now it says 0, but it's, yeah, there we go, 54, 70, 82. It jumps all the time. What else do I want to see here? Battery percentage. So this has never shown 100, by the way. They're fully charged, I know that. But it's telling me right now that the batteries are probably at about 65, 70%. It's not exact. So this unit right here is showing me right now inverter enabled. You can see the green light. If for whatever reason there's ever a fault in the system, it's a pretty smart system. This will light up red, and then you just push the clear fault and it clears it. Now, it's important for me to know what's going on with my system as best I can. So if I do have to put on the generator, if I do have to charge my batteries, I want to know that that power that's being generated in the generator is making its way into the system. So if I were to plug in the generator right now and start it up, and if the batteries were not fully charged, this little AC in will start to flash green once every 3 seconds. That's going to tell me that the power is being transferred from the generator into this system. Now, I have learned a very, very hard lesson. I was out here in the winter 2 years ago. One of many lessons, by the way. I was out here in the winter 2 years ago, and I was nervous about my batteries freezing. More about that later too. Basically, when it's minus 30 or colder, your batteries can freeze, and these batteries are $600 a piece, and there's 8 of them. So if I lose my batteries freeze, it's a $5,000 hiccup, plus the flight in and out, plus the lag time. It's like a $10,000 problem that I cannot afford to have. So I always want to make sure that my batteries are charged up at least 75-80%. Those batteries will not freeze. If they get down to 35, 40, 45%, they will freeze. And that's really important if you're going to design a system or put any system anywhere. You have to know what your minimum temperatures are going to be, and you have to have a way to deal with that, or at least understand about keeping your batteries fully charged or as charged as possible. Really important. So my lesson that I learned, I came out here, I was running my lights, running the refrigerator, and I was concerned, because it was going down below minus 30 every night, that my batteries were going to freeze, because that's what had happened in the past. It wears on me mentally, like nonstop. It's all I think about. And you know, in the winter, you're not getting a ton of sun, or at least the angle of the sun isn't high. The sun's not as strong, so it's a real concern. So I would come back here and I would fire up the generator, I'd plug it in, and I would hear a clicking noise. Click, click, driving me nuts. So I took the cover off this, and the AC in would flash green, and then it would hold green and click and shut off. And when I went to go look at my LCD readout, that usually will show the power. There's actually a little meter on that when you have the generator plugged in will show how much power is being taken from the generator. It was showing like 0. So I'm like, oh, we got a problem here. The generator must have an issue. It's not pushing power out, or there must be an issue with this system. And guys, I already showed you on a map where I'm located. I'm in the middle of nowhere. And to have my entire power system fail, which is also my communication system, which, you know, entirely allows me to be out here for a longer term basis, it's a huge problem. And I couldn't figure that out. I couldn't figure out what was going on. I called on satellite phone, the solar company, explained the problem to them. They couldn't figure it out. They couldn't troubleshoot it. I called Schneider Electric, who has an amazing customer service portal, by the way. They got back to me. They couldn't figure it out. Long and the short of it is, my batteries were fully charged. And the system will not allow you to charge a fully charged system. It's as simple as that. And it took an entire winter. It took a lot of panicking and a lot of stress to figure out that there was nothing wrong at all. Don't understand why Schneider couldn't figure that out for me. And don't understand why my solar guy couldn't figure that out for me. But that's it. So if you're fully charged, this thing will just make a clicking noise and will stop. You go to your panel here, your digital readout, it'll show you that there's no power being taken from the generator. So yeah, it makes sense now that, you know, the batteries are fully charged, but when you're out there and you don't know, you know, it was a cause for concern for sure. So that's the whole deal. When it's needing power and when your batteries are lower, that is just going to flash. It won't click. And you look at your readout and you're going to see tons of power being pushed into the actual system itself. So fun fact, that happened. One of 2 issues. The other issue being the batteries freezing, which I'll talk about here shortly. You know, there's your unit, inverter enabled. Here is my readouts, so you can see again the load's only 89 watts right now. It kind of goes up and down. Battery level looks good. Now if you come up here, this is your charge controller. This is important to know. So I'm just going to push that so it lights up. Right now I'm generating 867 watts, 26.8 volts, 32 amps. Now 860. See how it jumps all the time. Now there's a little bit of cloud cover. You guys see that cloud cover? It's not direct sunlight. When you get direct sunlight, this thing will jump. It'll jump over 1,000 easily. This is telling me I'm making power. So here's the generator. This is the fail-safe that gives me peace of mind out here. This is an EG 6500 CL digital auto voltage regulator generator. It can run 120 or 240 volts. It's a beast. It's heavy. It's on wheels. It's awesome. This is great. So when we first landed here, this was one of the first pieces of equipment that was out here back in 2015. This is what powered the tools and a lot of the equipment to begin constructing the cabin. Of course, that was replaced once the solar system got up and the battery bank was installed. But it's still such an essential piece of equipment. I don't use it for running power tools anymore. I have the solar system and the batteries for that. But again, several days of clouds, if you want to make sure you're never going to run out of power, just fire this up and plug it in for an hour or two and you're good. I've only ever run out of power twice that I can remember. And when that happens, the breaker panel just flips and everything shuts down. Come out here, fire this up, plug it in, and away you go. I'll show you the plug system. I'm sure a lot of you are probably thinking, this might look like a mess. It bothers me, actually. It does look like a mess. I'm going to put a couple hangers here, and then all of this cable is just going to get hung so that it's not here on my lovely foundation. But basically, this is it. I have 100 feet of cable here, so I can move this generator anywhere I need it to be. That's your hookup, and you're just going to put it in. I'm sure a lot of you are probably thinking, this might look like a mess. It bothers me, actually. It does look like a mess. I'm going to put a couple hangers here, and then all of this cable is just going to get hung so that it's not here on my lovely foundation. But basically, this is it. I have 100 feet of cable here, so I can move this generator anywhere I need it to be. That's your hookup, and you're just going to put it in. If you can get it in. So that's my plug, and I'm simply just gonna put it where it needs to be, lock it in place, and that's it. Fire up the generator and she'll be good to go. Very simple, works like a charm. And then when I'm done, I can just pop this back off, just throw that there for now, and it's as simple as that. So I wanted to take a moment and also talk about maybe some of the mistakes that I've made along the way, things that I would do differently had I had the option, or if I had the option to do it again. One of them is the location of this panel. It's not inside the cabin. It's not like a weather-tight system. It probably should be inside the cabin. And if I was starting from scratch, doing everything again, I would have built out a little room at the back of the cabin, and it would have been just kind of like the little mechanical room or electrical room, whatever you want to call it. But we didn't do that. So there's just the main living quarters, 2 bedrooms, and then there's a shower and vanity room that also houses my electrical, and I'll show you that too. But I would have done it differently. So having said that, I'm going to be redoing this here in the next few weeks. But basically, this box was just built outside. This whole panel system has been attached to the cabin from the electrician. And then I just put some of this house wrap. I got a tin on it. And then I have boards that go on the side and the front. So the only thing that's open on this system is up from the underneath. But it's still open. So lots of little spiders. I'm sure mice get in here. They don't chew through any of these cables, and that's a really good thing. But it's exposed. Never had any water or moisture in here because, again, it's house wrapped. I got the tin on it, and that seems to work pretty well, but there's always a risk. So I'm going to mitigate that risk here in the next week and just change things up a little bit in terms of weatherproofing this a little better, but it's not perfect. So the first thing that I would do is I would redesign the location of this, where it's coming into the cabin, where it's positioned inside the cabin. I know that when I was designing it and I was talking with my solar guy, he did mention that there's a hum that comes from this. And guys, there's a hum. It's humming like crazy right now. So the system is loud. There's no two ways about it. And when I say loud, like my ear is right into this right now. So of course I can hear it. When you're inside the cabin, you can't hear any of this. But if this was in the cabin, in a room that wasn't insulated, you'd be hearing a hum or feeling a little hum. And didn't want that. So that was one of the reasons why it was put outside. But I think I could mitigate that by just sealing up a room really well so that you wouldn't have to listen to that. Other than that, I think it should be inside. I definitely think it should be inside. Carry on to the batteries. Now for the fun stuff, the batteries here. So you can see that they're located under the cabin. I've built up a platform for them. There's 8 of them connected, so 2 rows of 4. And it's not the easiest place to get to, that's for sure. But basically, this is a provincial park. I couldn't have an area storing my batteries outside off the cabin footprint in case there was acid leak or anything like that. We wanted to mitigate that problem, so we put them up underneath. And you got your cables, your ground, you got just about everything. Now these batteries do require maintenance. You have to put distilled water, or at least I put distilled water in them. I do it twice a year, and you just remove the caps that are on here and fill it up. Now, keep in mind that obviously there's a beam here. This is a triple laminated beam. I got bugs in my mouth, but I can actually crawl up here, and I have a little more headroom, and I can get in there and do what I need to do. These batteries weigh 110 pounds a piece. And they froze in the middle of February once. I had to dig out all of this area. It was all full of snow. And one by one disconnect everything, -30, pull all these batteries out, and then fly in new batteries. That was a major pain in my butt. Probably the most effort I've ever gone to do a swap out on anything. And I'll get into the whole freezing of the batteries thing here in a second. But this is the system basically. These guys are storing so much power. Everything that's being generated from those solar panels and being inverted is being stored right here. It's a thing of beauty. Let's talk about these batteries freezing and that whole situation. One of the worst experiences I've had up here. Horrific, super costly, very expensive. And not only that, as I was dropped off by a ski plane. It was in the middle of winter, and I had a satellite phone, and that was it for communication, which of course is fine, but when you're trying to coordinate something because you have a problem, it's just a challenge. It's super difficult. So I was dropped off here. This is before we had Wi-Fi, the whole deal. Dropped off here, went to go turn on the power, nothing, no power. Like, what's going on? I went around to the side of the cabin where the battery bank is, and batteries were blown up. They had ballooned out. They had cracked. Whole host of issues. They're done. They're not going to work anymore. So I got on the sat phone, trying to sort this situation out, and talked to my solar guy, and he's like, "Yeah, your batteries froze, and I can sell you some new batteries if you want." It's as simple as that. So that's what I did, because I was out here. Wanted to be out here, didn't want to wait till spring. So we flew in 8 batteries at 110 pounds a piece, got them swapped out. It took me 2 days to get the whole thing done. And then what do you know, we got lots of power, and life is great. But the most important part of this is, why did it happen? How did it happen? And what can we all learn from this, so that if you're going to, set up a solar system, whoever's watching at home, you do not make this mistake. So why did this happen? Why did my batteries freeze, leaving me in a horrible situation, very expensive situation? Keep in mind, this was the first winter that I had this system set up. So baptism by fire, I guess. You learn the hard way. I talked to my electrician and my solar guy as to the best way to winterize this system. And I took their advice. I listened to what they said, and I followed. I made one critical error, and that's the error that cost me close to $10,000. I was told that the breaker panel that's at the solar panels can be left on, so that those solar panels are on, they're making power, or at least distributing power to the charge controller and to the inverter. And I still leave that on to this day in the winter. No issues with that. That power is just going to go, down the cable. You could turn it off, but that's not really a critical thing. What my electrician had told me was that I could leave the charge controller on. He's like, that way your batteries are always going to be staying charged. Turn the inverter off, turn the entire system off, save for the charge controller. And that was the critical error. That was the error that almost messed up an entire winter. So here's what happened. The panels get covered in snow. Now, usually because you have them tilted at a good angle, they don't get covered in snow too much. You can shed snow, but if you have warm weather and a little bit of rain, a little freezing rain, a little sleet, and those panels get covered, snow is eventually going to accumulate on top of that once they're first coated, and then they're just going to be coated and coated and coated. And when you come here in the middle of winter, you got to take a broom or whatever and brush it all off. That's just what happens. So the panels are now covered in snow. This would have been in November or December, who knows. Power is no longer being sent from the panels to the charge controller. That charge controller that I showed you guys earlier in the video with that little digital readout, well, that's taking a little bit of power off the batteries. Every day, day by day, month by month, who knows. Enough that it'll draw down your batteries over time. I didn't know that. Perhaps when I talked to my electrician, he didn't realize that the panels weren't going to be cleaned all the time, even though this is in the middle of nowhere. I fault myself for not understanding the realities of the situation. So, over time, batteries are being drawn down by that stupid digital readout on that charge controller. And because there is no power being generated from the solar panels, because they are covered in snow, the batteries with this system kick out at 44%. So the system is like an intelligent system. It'll kick out at 44%. Now the batteries are at 44%. Batteries will freeze at 44%. I guarantee you. When you get down below minus 30, minus 35, minus 40, these are critically bad moments for batteries that are not charged. And so the batteries blew up. They just froze and expanded and blew up. And they are done. So that's what happened. And I couldn't figure it out for a while. But that's what ended up being the case. So what I do is when I'm getting ready for the winter, I'll tilt those panels again to shed snow as much as possible. I leave the breaker panel on at the solar panels. You can shut them off. It doesn't really matter. But I make sure, doubly sure, to turn off everything. I go to that outside panel and I hit every single breaker. I shut it all down. There is no power being consumed at all. And if you leave your batteries in the fall at a fully charged state, so I make sure that they are fully charged a day before I leave, they will not freeze. I've come here now for the past 4 winters after that situation. Never had an issue with freezing batteries, but that was an expensive lesson. That was a horrible lesson, and something that I never want to revisit. The only positive I can take from it is that I learned the hard way that you don't do that, and I was able to get it sorted. It wasn't life or death at that point. I wasn't up here for 5 months with no communication. I had a communication system. If I didn't have a communication system and I was coming up here expecting that there would be power, it would be a different situation. It would be a different event, of course. Now, I should also say that, fully insulated cabin, I have a wood stove, lots of propane. loads of candles. That is what that also taught me, is to always have a lot of candles. And I made it through. I spent the time, made it through, no issues. But yeah, it was a horrible experience. So don't ever leave your charge controller or inverter on if you walk away from this system and there's going to be cold weather. So let's talk cost and break that down and see if this is something that maybe is good for you guys out there, depending on what your needs are. So I went back and I looked at my invoice as to what I actually paid for the solar panels, the mounting and racking, and the initial batteries. And including tax here in Ontario, Canada, it was $12,500. I also had to fly in two electricians, or an electrical apprentice and an electrician, to come and do the setup, as well as the wiring of the cabin. That was another $7,000. Now, keep in mind, that was a wiring as well. It's not just the solar. But when you look at those two things combined, we're already at almost 20,000 Canadian dollars. And then the concrete pad, all that extra good, stuff that gets thrown in, we're probably looking at around $23,000 or $24,000 when it was all said and done. And then of course the batteries froze, and I had to go buy new batteries at $600 a piece. That was another $4,800 plus the fly-in and all that. It was almost $10,000 when it was all said and done. So, depending on how you slice it, $25,000 to $30,000 Canadian to have a beautiful solar system that I get to stare at every day. I wanted to have a system that, as close as possible, would replicate my life in my house. In our houses, we don't worry about plugging things into the wall. We don't worry about blowing breakers. We don't worry about most things. Most people have 100 or 200 amp service at their homes. We actually take that all for granted, or at least I took it for granted until I hooked up a solar system and understood the limitations and also the benefits. But that being said, I wanted to have a large system so that I had endless power. Knowing that in the future, there'd be people here on a weekly basis, knowing that I'd want to power computers and Wi-Fi and power tools and other equipment. So that's why we built this system. Plus it was engineered for winter use when you're going to have a lot less sun. So we had to have a larger battery bank, and we also had to have more panels to capture whatever sun was coming in at any given point in time. So that's why I ended up going with this system. It's not a system that I'd recommend for everybody. I think it's way overkill for most people's needs. If you just have a simple cabin and you want to have some power, I would probably recommend a roof mounting system or a smaller pole mount system with 2 or 4 panels, 4 batteries, or even 2 batteries, depending on what your power use is, and it's going to be enough. It's going to actually be more than enough in most cases. The lights that we power this place with, in here in this kitchen and main living area, I have 1, 2, 3, 4, 5, 6, 7. These are 7 like LED pot light style that Home Depot sells all the time. I think that these are a 13 watt bulb or LED. That's not going to use a lot of power. Even our computers, Wi-Fi, most of that stuff is not going to drain a lot of power. You could get by with a very simple system for just a few $1,000s, maybe even less now. It's been 5 years since I bought that system, so I'm not really sure what the pricing of solar is like now. But for us, we had to have a fridge, and this fridge is what sucks most of the power. It's constantly on. The more times people go into the fridge or freezer, the more it's going to kick in. So we needed to have a system that was going to be able to handle not just lights and computers and Wi-Fi and television and all of the creature comforts of home, but also the fridge. And of course there are off-grid fridges now. You can get like solar fridges, propane fridges, but I didn't want to use propane. We thought about that, thought about it a lot, and almost went with it. But then we're always flying in propane, and propane is consumable. So long term, for an off-grid lifestyle, it's not sustainable unless you are continually spending money to fly in and consume propane. And it's a lot of money to fly things in, of course. You know, you can't just drive to the store and fill it up. So went with the electric fridge because for the most part, I'm always making power with the solar panels. So that's why I have the large system that I have. It's to run a fridge, computers, lights, everything else that you could possibly imagine having in your home, and to do it in winter. So definitely overkill. You don't have to spend the $25,000 or $30,000 that this system cost. But looking at the flip side of that, it's enabled us to have this commercial cabin. It's enabled us to continually book people here and gave us a competitive advantage knowing that people would have the creature comforts of home, that they could have just a regular fridge, wasn't going to be mucking around with propane, wondering if it would ever go out, not having to worry about, you know, all of those little things that some people worry about when they go to an off-grid cabin. People don't worry about that here. They come in, they flip a switch, the lights turn on. They have an electric razor or a CPAP machine or a radio or anything. They just plug it in. We don't have to worry about power generation from that standpoint. You can bring everything you want, and that's all I wanted. So flip that to today, to COVID situation. I'm able to be out here for the entire summer. I brought all my creature comforts from home, laptops, computers, you know, everything. And I don't have to worry about getting a supply flight because I'm completely self-sufficient, completely self-sustained, and it's all off-grid. So that's basically the cost structure and the reasoning behind the system that we went with.